Hey guys, welcome back. So what we're looking at today is lesson 21, also combining like terms, part 2. So let's go ahead and jump right in. All right, so seeing it differently. Some students are trying to write an expression with fewer terms that is equivalent to 8 minus 3 times the quantity of 4 minus 9x. So here we have each of their strategies and what they did. What we want to decide is, do we agree with any of them and why? And for each one that we disagree with, describe the errors. So Noah, I worked the problem from left to right and ended up with 20 minus 45x. So he had the original problem. So he did the 8 minus 3 to get 5. Then he multiplied the 5. He distributed it through. Is this accurate? No. So Noah is wrong. What did he do wrong? Oops, I spelled his name wrong. He subtracted first. We don't want to do that subtraction first. He needs to distribute first. All right, Lynn says, I started inside the parentheses and ended up with 23x. So she did the 4 minus 9x to get negative 5x. Then she multiplied that by negative 3 to get 15x, and then she added 8. Is this accurate? No, Lynn is also wrong. Combined unlike terms. We can't add together the 9. We can't subtract the 9x and the 4. They're two different things. One is a number with a variable. The other one is just a number. They are completely different things, so we cannot combine them. We can only combine constant numbers together, like the 4, the 8, the 3. Those are constant things. Or the x's if we had multiple x's in there. So combined unlike terms. So Jada says, I used the distributive property, ended up with 27x minus 4. So we look, she multiplied this 3. She multiplied it by just a plain 3. So 3 times 4 gave us 12. 3 times negative 9 gave us negative 27x. Then she distributed this negative through, so we ended up with 8 minus 12 minus negative 27x. And so then that became positive because minus a negative is positive. So positive 27. 8 minus 12 is negative 4. So Jada is correct. So we could take and try various values, plugging in values of x into this and the original equation and seeing if it would give us the same exact value, and it would. All right, now Andre, let's find his error or see if he's right. Andre, I also used the distributive property, but I ended up with negative 4 minus 27x. So distribute it, but look, they got the 12, the minus 12, that was good, but they only ended up with a negative 27. So what happened? We have a negative here. They dropped their negative in there. So Andre multiplied negative 3 and negative 9 and got negative 27. If we multiply two negatives, do we get another negative? No, we get a positive. So he had a mismultiplication. All right, grouping differently. Diego was taking a math quiz. There was a question on the quiz that had the expression 8x minus 9 equals 8x minus 9 minus 12x plus 5. Diego's teacher told the class there was a typo and the expression was supposed to have one set of parentheses in it. Where could you put the parentheses to make a new expression that is still equivalent to the original expression? How do you know that your new expression is equivalent? So basically with this, we want to keep it so that it won't change our solution at all, but it'll have parentheses in it. And so we're working to get fewer terms in the end with all of these. So fewer is your keyword for this lesson. So one way that there could be parentheses in it is if we just put parentheses around the whole entire thing. Then nothing would change. All of our signs would still be the same as what they are, but there would be parentheses. Another way we could do it is to group just the first two. By grouping these two together, it's not changing any of the signs, but we still have parentheses. Now, if we were to put parentheses around the 12x by itself, then, or the 12x plus 5, then we'd have to distribute the negative. Because of that, that would change it, because then we'd be subtracting 5 instead of adding it like it is in the original. All right. For number 2, where could you put parentheses in the problem to make a new expression that is not equivalent to the original? List as many different answers as you can. So there's a whole bunch of different possibilities for this. We can put parentheses all over the place to change it. One way is like that last one I just said, where we'd have 8x minus 9 minus 12x plus 5. If we simplified this, we'd get negative 4x minus 14. Another place is 8x minus parentheses 9 minus 12x plus 5. This would give us 20x minus 4. We can also group all 3 of these. So we'd have 8x minus 9 minus 12x plus 5. It's supposed to be an x. And this would equal 20x minus 14. We can group everything but the 8. So 8 times x minus 9 minus 12x plus 5. That would give us a negative 88x minus 32. We can do that with everything but the 5. So like I said, there's a whole bunch of different possibilities for how we can take and do these. And then the last one that I have would be 8 times x minus 9. Bring the negative 12 back outside. We'd end up with a negative 4x minus 67. So, like I said, a whole bunch of different possibilities. So, parentheses can completely change what the problem is and how we simplify it, depending on where those parentheses go. So, it's crucial to be able to understand that parentheses will change a problem, because, as you know, parentheses come first in our order of operations. So we need to do any distributing first to take care of the problem when we take and do these. So keep that in mind. All right, if you guys have any questions, feel free to ask.